Hello everyone, in this session we'll be learning about how to sketch a Bode plot if a transfer function is given. Before I start off with how to sketch a Bode plot, let me tell you what it actually is. It is the frequency response of a transfer function where one plot is the magnitude versus log omega and another is the phase angle of the transfer function versus log omega. So it can be drawn for both open loop as well as closed loop systems, but it's usually drawn for the open loop ones. So the advantage is that the multiplication of magnitudes can be converted to addition, and it is also a simple method to sketch an approximate log magnitude curve. So first of all you need to sketch a Bode plot is a logarithmic graph sheet. These are called semi-log graph sheets. As you can see in here, you have, putting it the way around. As you can see, it starts with 1 and ends in here, and starts again with 1 and ends here, starts with 1 again and ends here. So as you can see, this semi-log graph sheet, the way you're gonna mark this graph sheet we'll be talking about later, but for right now let us start plotting a Bode plot. First of all, we'll have to do some calculations, so all you need is an example and off we go. So in this example, I'm taking the transfer function g of s is equal to ks squared by 1 plus 0.2s into 1 plus 0.02s. So this is my transfer function. I need to give the Bode plot for this transfer function. So to find a Bode plot, we first need to find out the different magnitude and different phase angles for a particular frequency omega. We need to find out magnitudes as well as phase angles. So first of all, let us consider our transfer function which we already have here. One thing we have to remember is a transfer function, when you want to sketch a Bode plot, it needs to have 1 here. So the standard form will be something like 1 plus st1. You need to have a 1. Say this is your this is your transfer function. You need to have 1, and again 1 plus st2. 1, that is the standard. So now coming back to how we are going to obtain the magnitude. First you have g of s is equal to ks squared by 1 plus 0.2s into 1 plus 0.02s. So the major substitution we are going to do is s is equal to j omega. So everywhere where s is there in this equation, replace it with j omega. So you get the equation g of j omega is k into j omega square by 1 plus 0.2 j omega into 1 plus 0.02 j omega. So this is your transfer function after you have replaced s with j omega. So now you need to find out what are called corner frequencies. So let me make a table for these. Let me write something like term and corner frequency, which is omega measured in variance per second, and then comes your slope. Let me divide a column in here, making it more clear. Your slope, and then comes your change in slope. So slope and change in slope, they're both in decibels per decade. Decibels per decade. So as I already told you what a decade is, this is a decade, 10. This is another 10. So putting that aside, if you look at this equation, how many terms do you have? How many individual terms do you have? So let me write them down for you. You have j omega square. Don't you have that? You have it. J omega square is one term, and 1 plus 0.2 j omega, that is 1 by 1 plus 0.2 j omega. It's in the denominator. Don't you forget that. It's going to change the entire plot if you're forgetting that. And the third term we have is 1 plus 0.02 j omega. So 1 by 1 plus 0.02 j omega. So now we need to find out the corner frequencies. And for the first one, you can leave a blank in here. And the slope, this is really easy to find out. When you want to find out a slope, just look at the term. Is the term in the numerator or in the denominator? It is in the numerator. So the slope is going to be positive. It is a positive. And what is the order of this term? It's a square. You have a square here. So you write it as 20 into that. You have 2 here, so this is 40. And here you have what is this? Is it in the denominator or in the numerator? It's in the denominator. So you get a negative slope. And what is the degree? It's 1. You don't have any square in here. So 20 into 1 is minus 20. And the same goes with our last term. So now coming to the corner frequency for the second one, let us write it as omega c1 is equal to whatever is the coefficient of this j omega in here. Write that as 1 by 0.2. So what you're gonna get is 5. And for this, I want you to take your calculators out and calculate it. So 1 by 0.02. But this is gonna be simple because you're just gonna multiply that with 10. So it's 50. So omega c1 is 5 and omega c2 is 50. And you have slopes for different things. Now you need to find out the change in slope for these things. So for the first one, the change in slope, you can actually leave the first one. And for the second one, the change in slope is this, 40. You're going to write down 40. And because it's a change in slope, you're going to add this. You're going to add 40 and minus 20, which is equal to 20, right? And now you're going to bring this 20 here, and you're going to add this minus 20 to this. So 20 minus 20 will be 0 decibels per decade. I hope you're clear with the last column. Change in slope is equally easy. You're going to write down this slope, and you're going to add the slope. You're going to write down the first slope in here and add the next one, so you're going to gain 20. And then you're going to drop down this 20 and add the slope. And if the number of terms are more, you're going to repeat that, so on. So now you have 2 of the corner frequencies of the terms you have given, terms you've already given. So now you need to find out the magnitude of these at different omega values, at different corner frequencies. So the first thing I'm gonna do is I'm going to to plot the Bode plot, I'm going to take one frequency which is lower than 5 and another frequency which is more than 50. The rule is you have to take a frequency called omega L, which is less than the least corner frequency, and you need to take a frequency omega H, which is greater than the maximum corner frequency. So now the only thing that is left is so what do you think is a good value for omega L? So since we have 5, I think I'll go with 0.5 radians per second for my omega L value. and for my omega h, because it's a 50, I'm going to take 100. Let me just make it clear that you can take 75, you can take 51, you can take 60, you can take whatever value you want for omega. So the only condition is one frequency should be less than omega c1 and the other should be greater than the maximum corner frequency which you have obtained from the terms. And now we need to find out the magnitude at different omegas. So there is a formula for that. Now let me write down our different omega values. Omega L is 0.5, omega C1 is 5, omega C2 is 50, and omega H is 100. So these are our different corner frequencies, and we have to find out magnitudes of this at these respective corner frequencies, and then we can plot the magnitude plot of the Bode plot. So now and magnitude, I just forgot to mention, is denoted by A in most cases. So now to find out the magnitude. Now what is the first term here? What is the first term? You have j omega square. Am I right? So the formula is, for the first two frequencies, that is for omega L and omega C1, you're going to write A at omega L is equal to 20 log. What is this? This is j omega square. Remember, just take the first one. 20 log j omega square. So for the respective omega value, you gotta write 20 log. You're going to write 0.5 square. So that is going to be minus 12 decibels. Just take out your calculators and do that. And the next magnitude we're gonna find out is AC1, which is at omega C1 is equal to 5. So now that is 20 log at j omega square, and in this place of omega this time you're gonna write 5. 20 log 25, and 20 log 25 is 28 decibels. So this is how you calculate for the first two frequencies. For the first two omegas, you're going to calculate in this way. For the next ones, you have a formula like at omega is equal to omega C2, you have AC2 is equal to slope from omega C1 to omega C2 into log omega C2 by omega C1 plus magnitude at C1, which is 28. So now slope from omega C1 to omega C2 is, you're going to tell me looking at this, what is it? It is 20. Omega C1 to omega C2, the change in slope is 20. So you're going to write 20 into log. What is omega C2? Omega C2 is 50 and omega C1 is 5, so 50 by 5. And A at C1, which is the magnitude at C1, is 28 decibels. So by solving this, you get 48 decibels. Right? So now, once you're done, it's actually simple. 5 ones and 5 tenths, log 10 base 10 is 1, and 20 plus 28 is 48. So AC2 is 48 decibels. And in the same way, at omega is equal to omega h, A at omega h is equal to slope from omega C2 to omega h into logarithm of omega h by omega C2 plus magnitude at omega C2, the previous magnitude, that is your 48. Now the slope is, if you can tell, you're gonna tell it with ease, it's 0. So 0 into whatever is anyway 0, I'm not writing that down, plus 48. So this is also equal to 48 decibels. So now you have everything you need to plot the magnitude plot of the Bode plot. So at different corner frequencies, 0.5, 5, 50 and 100, omega value and your magnitude value. At 0.5 you have the magnitude as minus 12, at 5 it is 28, and 50 and 100 it is 48. So by these values we can plot the magnitude plot of the Bode plot. Now we need to find out the phase angle plot of the Bode plot. First, for the phase angle plot, we need to consider the transfer function which we already have, and the angle of g of j omega, as you all know, is this is just j omega square, so you just gonna write 180 degrees plus this is in the denominator, so you're gonna go for a minus tan inverse of what's the coefficient of this? It's 0.2. So you're gonna write it as 0.2 omega. Again, this is in the denominator. So you're going to write minus tan inverse of, what is the coefficient? It's 0.02, 0.02 omega. This is your formula for finding out the phase angle plot. So now at different values of omega, plot out using this formula, write down your phase angles. So for omega, phase angle, just make a table. For example, omega is equal to 0.5. You need to write 180, and tan inverse 0.2 into 0.5 is 5.7, and tan inverse 0.02 into 0.5 is 0.6. So you're going to write 180 minus 5.7 minus 0.6. So that is going to be equal to something around 173 point something and 7. Okay, so you're gonna write it for different values, and for 1 it's going to be, and when omega is equal to 1 you're going to get 168. When omega is equal to 2, I'll just jump to 5. Why take so many values? When omega is equal to 5, I got 130. And using this formula, just substitute omega here and then tan inverse using your calculator, or you can use many online sites which will offer you to find the logarithmic values of the given functions. And 10 you have 106. And for 50 and for 100. For 50 I have 50 itself, and for 100 I have 30. So these are the different omega values and phase angle values. So this is going to make my phase angle plot. These are the values that are going to give me the phase angle plot, and what we have got here are going to give us the magnitude plot. So now let's get to some plotting of Bode plots. First, all you need is a semi-logarithmic graph sheet and look at this. This is your semi-log graph sheet. You have many readings here, and on the left side of the graph sheet you're going to take A, which is your magnitude. You're going to take magnitude on the left axis, and you're going to write down omega values on the bottom of the axis. So in our case, omega values are ranging from 0.5 to 100. So we need to start writing 0.1. This is omega in the bottom axis. So this is 1 decade. This is another decade. This is another decade. So how you're going to write down in a semi-log graph sheet is, this is 0.1. You're going to write 1 here. This is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. And since this is a semi-log graph sheet, in the next decade, this value is going to be 10. So this is 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is going to be 100, and this is going to be 1000. So these are all your omega values in radians per second. So on the left side, you're going to take magnitude, and on the right side, you're going to take a phase angle. So now take scale as it suits your Bode plot, as it suits your own values. And in my case, I think we're starting with the -12 and we're going to 48. So let's take 10. Let me say this top thing is -20, and the next thing is -10. This is 0. This is 10. This is 20. This is 30. Okay, just a second. I'm extremely sorry. I'm taking it the other way around. This is +50. This is +40. This is +30. This is +20. This is +10. This is going to be 0, -10, and -20. So this is +50, 40, 30, 20, 10, 0, -10, and -20. I'm sorry for marking it the wrong way previously. So now, once you got all your values right, just look at what 0.5 A is -12. So 0.5 is here, and A -12 is going to be somewhere over here. So this is A -12 for a corresponding frequency 0.5 -12, and for 5 it is 28. So now I have marked out for different values, for 0.5 -12, for 5 28, for 50 48, and for 100 48. Now for the Bode plot, we need to join all these dots using a scale. So this gives you your magnitude plot of the Bode plot. So now you need to plot the phase angle plot. Now if you just have a look at the different angles you've got for different frequencies, they're ranging from 170 to 30. So we're going to take a scale of 180 to 30. So let us write 30 here. Let us write 30, 0, 60. You have a negative? You don't have a negative, so no worries. 60, 90, 120, 150, 180, 210. So now, for different omega values, plot the respective phase angles. For 0.5, you have 173.7. This is 180, and for 0.5 it's 173.7. You're going to get something here. So now I've plotted, for the respective omegas, I've plotted out the phase angles. So all I need to do now is join all these freehand. For the magnitude plot we use the scale, but for the phase angle plot we go freehand. So this is how you plot a Bode plot for a given transfer function. For any doubts, you can just drop in the comments. For any improvements I can make, you can just drop in my comments. So hope you found this informative. If you have an exam tomorrow, all the very, very best. Thank you and have a lovely day ahead.